Alright, good afternoon everyone. Welcome to today's Sec 4 math lesson with me, teacher Jason, over here as usual. Alright, today's lesson is going to be a little bit unusual. In what sense over here? Okay, so we'll be going through our mock paper accordingly as well for today. I understand it is actually specified that you need to attempt the mock paper first, but I do know some of you all have not attempted the mock paper yet. So I'll give you all some time to actually download the mock paper right now in the Genie Ask platform. For those who has not attempted it, alright, it is actually blasted in your Genie Ask platform. So I'll give you all about a minute to do so to actually download the paper before I actually start the class for today. Alright, so I'll start proceeding the class at about 2:01. So do me a favor, alright, go to your respective Genie Ask classes to download the mock paper. Alright, the message should have been blasted again. So just make sure you have the paper with you in the PDF format. Okay. So just a heads up as well, each of the bubble questions will only be 30 seconds long because it is sort of, we are expecting most of you to actually, or in fact all of you to actually complete it as such. So if you actually need more time for a certain question, if you've not attempted it and you need more time, please feel free to let me know, alright? I will do it via the traffic light side, okay? Please feel free to let me know if you need more time as well, okay? So I'll specify what you all should do for the traffic light later on. Okay, so I hope you have downloaded the paper already. Let's get started. Okay, so just some general things to take note. Be patient and understanding. Observe gracious and respectful behavior, even in digital space. So if you need to specify certain questions or in particular, just let me know. Lastly, ask good and relevant questions for today. And so what are we going through today? Okay, so today will actually be one of the mock paper revisions that we will be covering as well. So in this case, we'll cover part of paper 1 as well. So you realize in this case, the marks is a little bit different if you were to actually attempt past papers already. In this case, the previous code that you all attempt, if you realize 4048, alright, this one over here is actually the old syllabus. Okay, so this is the old syllabus that you will have to do. Okay, but now starting off this year, they will actually start off with the new syllabus over here, 4052. So this is the one that you'll actually be focusing on instead of this one over here. Now, what is the difference over here? Okay, 4048, if you actually realize, paper 1 is actually 80 marks, paper 2 is 100 marks, okay? And in this case, the timing will differ. But for this case, starting with the new particular syllabus, paper 1 and paper 2 will have the same amount of marks, 90 marks, henceforth 2 hours and 15 minutes. What is the difference over here? Paper 1 will focus on short answer questions, 25 to 26 of them in general. So usually short answer questions. What about paper 2? Alright, so paper 2, one of it will actually be gone through in 2 weeks time. So I'll elaborate more on that. And as well as approved calculators are also allowed. So your Casio calculators, Sharp calculators in particular are actually sort of allowed. Okay. Now I hope you guys are getting started. So just a refresher. Only some of the questions will be gone through for today instead of every question. Alright, this is actually because we are expecting, by right, we are expecting most of you all to do the paper, but I understand it might be a bit time consuming over here for you guys. So we are actually trying to cover some of them. So this lesson, for those who have actually went for the previous lesson, is going to be a little bit different. So don't worry, I'll guide you all accordingly to actually see what are the type of questions that we are going to go through. So you can refer to your PDF, and in fact, for the first one, this is the question that you will need to attempt. Now, this question is only 30 seconds long, but that's where I'm going to use the traffic light over here to help you guys to initiate some feedback. Okay, if you need more time, give me the green color signal. Okay, if you need more time. If you don't need enough, if you feel that it is okay, all right, just give me the red color signal. All right, yellow, please don't give me yellow, don't half. Okay, it's either you need more time or don't need more time at all. So green if you need more time. Okay, so I'll just initiate the feedback. Green if you need more time, red if you don't need more time. Oh, okay, so most of you have actually attempted the, okay, I'll wait for the response. Okay, seems like most of y'all need more time. Alright, so don't worry about it. You can start and proceed with the question now. I will start launching the bubble launcher in 1 minute. Alright, you can start with the question now. So this is the first type of question in the mock paper that will be gone through. Okay, look at this question carefully. Okay, see and try to see what we have. Okay, so start the question now. I will launch it in about 30 seconds time for you to put your answers in. Okay, in about 20 seconds, I will launch the bubble launcher, so get ready. Alright, launching the bubble launcher in 3, 2, 1, and let's go. Okay, that is good. Okay, 20 more seconds for you to input your answers. Let's see how we tackle them. Okay. Alright, last 10. Okay, alright, seeing your feedback, most of you got it down. That is good. Okay, so how do we tackle this question? So, they want you to find the largest possible integer value if the median is actually 22. So what does it mean? We call median, we need to arrange it in the ascending order. Alright, so the median has to be 22. So if I were to rearrange it, it is going to be 18, and then 22, 29, and then 30. So we call, guys, in this case, this one has to be the median. Now, if this one is in the middle, okay, that means what happens, I have 5 numbers, okay, 2 of them has to be on the left, 2 of them has to be on the right. So picture this, should my number be on the left or on the right? Okay, L as in left, R as in at the right. Okay, so can anybody give me a response? Should my number over here be on the left or on the right? So that means, is it going to be here or is it going to be here? Okay, Denisa said right. Anybody else? Okay, Gabriel says left. I have a mixture of responses. Okay, so I think I do have some response over here. So take note. Let's do 2 scenarios, alright? Suppose I put B on the left. So let's say, because on the left, it can be any scenarios. And I want the largest number. Okay, then that's right. Okay, so in this case, I would say most of you all got it. Okay, that's good. In the left and specifically on this side, because I want the largest number. So therefore, if I want it to be 22, okay, so most of you all know that it's going to be here. And I want the largest number. That means it has to be larger than 18. So therefore, what happens is, if I want the median to be 22, in this case, I want the largest number. So therefore, it has to be here. And also, this number over here, largest. So the answer is 22. So for those who answer 17, okay, it's not the largest number. And as well as for those who answer 15, take note over here, I want the median of an odd number. Median of an odd number, 22, is just the number itself. So therefore, in this case, B is 22, and this is the largest possibility. So the largest possible value. Largest possible value of B. Okay, I want the largest. If it's just a value, it will be 21, it can be 17. All the answers are correct. That's why the question specifies the largest possible value of B. Very, very important over here. Okay, so I hope you all got this down. Very important pointer. Most of you, I think, got it right. So that's a good note. Okay, moving on to the next question that I want to cover. Part B. Now, I want the smallest possible value this time. But what is given? Okay, so looking at this, I'll give you all about a minute to try before I continue with this question. Okay, a minute again. I will launch the bubble launcher in 10 before I start the bubble launcher. Give you some time to try. For those who have not to attempt, for those who have attempted, just bear with me for a moment, for a minute. Alright, understand that you guys are doing so well in that, but don't worry, we are doing this together. Alright, so don't worry about it. Okay, for the rest over here, I hope you are doing good, doing well. For the others who are attempting this mock paper as we are going through this, I hope you are doing well as well. Okay, as such. Okay, so I'll launch it in 10 more seconds. All right, so just key in your responses once you have it done. Okay, 5 more seconds before I launch the bubble launcher. 4, 3, 2, 1. Let's go. Alright, that is good. I have, let's see the responses over here. Okay, what is given to you first before you answer the question? Alright, always remember specific questions, what is given to you. Okay, look at the keyword. 5 more seconds. Last 3, 2, some of you, I think you fell into the trap, but let's take a close look. First things first, I believe you all know what is the mean over here. Okay, mean, looking at the responses, take note, mean over here, it's actually taking the average of these numbers. So I'm summing all of them, 18 plus 29 plus B plus 22 plus 30. And I'm dividing by the total numbers over here. So there are 5 numbers, I divide by 5. Okay, now that's the first part. Some of you actually answered number 4 over here. So take note, I have 5 numbers. So count the bottom correctly. Okay, now the main keyword over here is greater than. So when I talk about greater than, 2 scenarios can happen. 1 or 2. Okay, so instead of 1 or 2, okay, let's say this is A, this is B. Which one should I use for this specific question? A or B? This will determine your answer for this question. Is it A or B? Okay, Denise, that's correct. Anybody else wants to try? Is it A or B? Very important over here. Very good, Gabriel. That is correct as well. Okay, any other responses before I go through this one? Okay, so seems like most of you got it down. This is actually A. Okay, greater than. Okay, what is the instance where we will use B then? Can anybody tell me? What is the keyword? If I were to use B for this question, what would the question say? What would the question say? Can anybody tell me? Okay, is it greater than, or is it they will phrase it a bit differently? If they were to use this one over here, okay, it's going to be the keyword. Yes, thank you, Kavya. Thank you so much. It will say at least. The keyword here is at least, in this case, 36. Okay, so the keyword here is at least. So therefore, take a very close look at these keywords over here. Greater than, at least. These are the 2 key things that will actually sort of haunt you if you were to do inequalities. Okay, so just take note. Now, I'm going to erase this part and continue my working over here. So we know this is going to be greater than 36. Solving for that, okay, you're going to have 99 plus B over 5 is going to be greater than 36. Manipulating it, I have 99 plus B is greater than 80. B is 81. Now, some of you may think, oh, B is greater than 31. So I will choose 81, sorry. So I'll choose just 81. But take note, this is a strict inequality. I want the smallest possible integer. Smallest possible integer. So what's the smallest possible integer? The next bigger one, which is 82. Don't write 81 because 81, it's not included for this. So answer is 82. Okay, so I hope you all got this down. Okay, I hope you all got this down because of the note of greater than. Okay, now moving on to my next question over here. Okay, the next question, seen it in Sec 1 a lot. So the answer is given to you already because it is assumed that I've gone through. But take note, how do we actually find out the pattern over here in diagram 9? So if you take a look very closely, firstly, identify from the diagram as shown below. Diagram 1, diagram 2, 3, 4. Try to see the pattern. I'm looking just the number of squares. It does not matter how the pattern is like. I'm just looking for the number of squares. So diagram 1 has 1 square. Diagram 2 has 3 squares. Diagram 3 has 5 squares. Diagram 4 has 7 squares. So what is the pattern over here? If you look at the answer, it's just adding by 2. So adding by 2, adding by 2, adding by 2 over here. Then afterwards, they want the 9th square. So what can we do? Okay, from the 4th to the 9th, how many times must I add? Okay, if you add 1 time, so that's where you go logically, based on the question part. Go 1 time, you go to the 5th. Go another time, you go to the 6th. Usually, this type of questions, they won't ask you to go too far because you haven't derived the general formula yet. So you just go on 7, 8, 9. So sum these 9 times, that's where you get the answer, 17 over here. So it's just 7 plus 2 plus 2 plus 2 plus 2 plus 2 in this case. But you may realize, if I want to have the far side, and I say, hey, let's find this n term first, if you recall. 1, 3, 5, 7. Can I do so? Answer is yes and no. Yes, in a way, is you can do this at your back end. So you can figure this out at the back end and you solve for the answer. No, it's because you haven't done this yet. So there must be a particular way that you need to express this out first before we go on to the general formula. Now in this case, this is a usual notion of a general formula that will come up to you because these questions will be having a common difference. A common difference over here, just follow this formula over here. Tn is equals to A plus n minus 1d. This specific formula is actually gone through if you proceed to JC, but again, I will not emphasize on why do we have to go through here again, because it's more of a shortcut, very general convention of a question type that we will go through. So what is A, what is D? Okay, A over here is my first term. Okay, N over here will be the term number. Then can anybody tell me, what about D in this case, for those who are familiar? Help out the friends over here. What is the notion of D over here? Okay, in this case, D over here, very good caveat, but be more specific over here. Okay, add one more word. What must the difference be? Kavya has thankfully has offered her note over here, but what is the thing over here that I must specify? Okay, because difference, I can say 1 is 2, 1 is 3, 1 is 4. So it's adding up, again, the difference between, say, them, it's 2, 3, and 4. Okay, the specific word that I am looking for over here is not just the difference, but it has to be, keyword over here, common. So that means if I take the difference between this one and this one, it has to be common too. If I take the difference between this one and this one, it has to be common 2 as well. So that is something you have to take note, and 2 as well over here. So that's why n term follow the convention over here. First term, n plus n minus 1. Leave the n over here because I'm finding just the n term. D over here is the difference of 2. So that's where you just have to expand it out, simplify it more. This is what you get. And in fact, to be more specific, you can add on and say, I'm looking for the Tn. That is the n term. Okay, this is the specific way of writing it. It is the specific way of writing it. Okay, now let's boil down to the main question that they will ask. And in fact, even in papers as well, they will ask this. Okay, very standard in Sec 1, but let's see how we answer based on these conventions over here. Does a diagram with 1, 2, 8 squares exist in this sequence? Explain your answer. Looking at this, okay, for this one, I will not give you all too long, okay? I will provide you all, for those who needs it, the Tn to be 2n minus 1. I'll just give you all about 45 seconds before I launch the bubble launcher. And look at the arguments over here before I actually start the bubble launcher, okay? So I'll give you all some time, start now. I will actually launch the bubble launcher in about, say, 2:20. Okay, so for those who are doing, you can start now. I will actually continue I will launch the bubble launcher in a short while. Okay. Okay, so for those who have done it, again, try to sort of see which argument fits into your explanation. Okay, 15 more seconds before I launch the bubble launcher. 5 more seconds. Last 4, 3, 2. Alright, let's go together. Okay, very good. Okay, I see a mixture of responses between two particular scenarios. Okay, I will go through that. I understand there's gonna be a little bit conflicting over here, but let's see how we fare. Okay, last 10 seconds. Last 3, 2, 1. Okay, most of you all have the responses, I understand, between two of them, which is number 2 and number 4. For those who answer number 1 and 3, alright, take note, just be careful with your manipulation. If I were to solve it, 2n minus 1 is equals to 1 to 8. I have 2n is equals to 1 to 9. Solving it along the way, I'm going to get n is equals to 64.5. Now, we cannot have a 64.5 term. So therefore, these two things are actually not correct. Now, looking at zooming it into 2 and 4, both of them seem to feel like they are the same thing. But take a close look over here. One is saying that it's not a whole number. One is saying it's not a positive integer. Now, in this case, I understand some of your schools may have actually said, whole number, I still accept. So what's the difference over here? Zooming into their notions over here. Okay, let me just write it out over here. When I talk about a whole number over here includes two different things. One, whole number, I'm talking it about a positive integer. Yeah, that's right. Denise has specified it correctly. Second one consists of the zero. Okay, 0. Now, in this case, if you were to write 0 over here, okay, it is not really correct because I cannot really have a 0th term. Thank you for the note, Denise. I cannot have a 0th term. Okay, so in a way, this argument is not strong enough. Okay, not strong enough. Okay, because what will I say? Okay? If I were to reflect this statement, if n is a whole number, that means my diagram will exist. But can I have a 0th term? For those who have learned A math, you might have confused yourself with the binomial theorem part. So just take note, when you're subbing for the nth equals to 0, you're looking for the constant term. For those who take A math, yeah? So for those who did not, just bear with me for a while. For the constant term, without the variable, that is when you sub n equals to 0. But for the 0 over here, you're looking for that particular term. When we start with a number patterns, we always start with the first term. We cannot start with the 0th term because 0th term, you're starting sort of like, okay, let's start off with nothing. But it is not very intuitive to start off with nothing. Okay? But for binomial theorem, for those who take A math, when you sub in 0, you're subbing it and finding a term that does not have sort of like the variable involved if we were to talk about the expansion. So just take note for that particular part over here. Okay, so a little confusing for those who do not take A math, but in general for number patterns, focusing on that, when we talk about a whole number, okay, there's a 0th term over here. We cannot start with nothing. We cannot start with a 0th term. 0th term means we start off with nothing, so it doesn't apply for number patterns. Okay, so I hope this is a little clearer for those who choose 2, and in this case, why the more specific answer here is actually 4. In this case, to play safe, I would recommend, or in fact, I would kindly suggest or kindly advise you all to choose number 4 because positive integer, we have 1, 2, 3, 4, 5. We definitely always start off with the first term. Okay, so to be more clear. Alright, so I hope this is a good learning pointer for those who chose between 2 and 4 accordingly. Okay, now moving on to the next question I'm going to cover, okay, which is number 5. Okay, so this is in this case a way whereby they will force you to sort of choose a question from what is given. So look at the question over here. So you may wonder, why do I want to approach it this way? So a box contains 4 golden balls, some silver balls, and twice as many bronze balls as golden balls. So sounds very confusing, but let's take a close look. 4 golden balls, some silver balls. Okay, try to see what we can get. Twice as many bronze balls as gold balls. So that means if gold balls is 4, how many bronze balls should I have? Okay, can anybody tell me? Looking at just this statement over here. Very good, Denise. Okay, very good, Kavya. Awesome job. So twice as many bronze balls as gold balls. Gold balls. Okay, gold balls. Okay, so if I have 4 gold balls, I should have 8. Now looking at this question, they tell you the probability of selecting a gold ball at random is 4:17. They only give you this probability over here, 4/17. Then they ask you to find the probability of selecting a silver ball. Now, how do we even start? How does the probability even help? That is where a technique comes in. Look at whether, in this case, my number corresponds over here. In this case, 4/17. In this case, they do, right? So can anybody tell me, based on this information over here, what can I say with this particular number 17 over here? Does anybody wants to try? What is this number 17 that will help to solve this question? Correct, Kavya, that's essentially correct. Anybody else wants to try before I give out the answer? Very good, Gabriel. I think most of you all got it. Anybody else still wants to try? Very good, Denise. I think most of you all got it. That's a good job down there. So what happens? They can give you 4 gold balls. Okay, if the number corresponds, it will be 4:17. But let's say, they don't give you like that first. They give you, say, for example, let me see what's a number that makes sense. Let's say my probability, I don't give you 4:17. I give you, let's say, I give you, of course we are following this flow, but let's say I change the question, I give you 2:11. Now the probability selector is this way. What should I do first? What can I do first to ensure I solve this? So it's not 4:17, let's say I change the question into 2/11 instead. Very good, Gabriel, that is correct. Correct, Kavya, that's good. Anybody else wants to try? Okay, so I think some of y'all got it, some of y'all did not. So let me just roughly go through. Okay, because when we do probability, right? Okay, we are actually selecting the total from the total. How much are we selecting? So the probability fraction that is derived is essentially how many items you are getting over here on top of the total items. But only 2 scenarios can happen. One, the fraction is factorized and simplified. In this case, is this scenario. 2, the fraction cannot be simplified further, and the number over here is the same, which is essentially this question over here. So if the question gives you the first scenario I'm giving, which is this one over here where the fraction is further simplified, and you need to sort of do something, which in this case I times 2 over here, to give you the number that is expressed in the question itself, then you have to do it, and this is the actual number over here that corresponds to this, and in this case, the total number of balls is 22. So this question goes through the second scenario where the fraction is sort of simplified, and you need to multiply by something, in this case multiply the denominator or numerator by something, to give you the number over here. In this case, you have to multiply the numerator by 2 to give you the number that is the same. Okay, so this is the second scenario, but over here, we are only going through the first scenario over here, whereby the fraction is simplified already. The items is as such 4 and 4. So therefore, we know the total number is 17. I have 4 golden balls, and based on the question, twice as many bronze balls. So therefore, I know number of silver ball is 5. Total number of balls is 17. So probability over here, that's why you have 5 over 17. Very common kind of questions. And even so for those who are in Sec 2, I think I do have some Sec 2 students over here. Yes, Sec 2. Sec 2 students over here, take note, okay? If you are in Sec 1, might be a bit hard for you to follow, so just try to see whether you can catch up. Okay, Sec 2 students over here, this can be a question that comes up indirectly as well. So try to see whether you can get the track. Now, for the next question that I want to go through, this is also applicable to Sec 2 as well. But let me give you the probability for those who wants to try. So we know from 5A, alright, as well, 5A, the probability of selecting, in this case, a silver ball is going to be, in this case, 5 over 17. Now, how do we actually start out this question? Okay, I'll give you all 1 minute to think about it, or in fact 1 minute 30 seconds in this case to think about it. And I'm gonna drop a hint for those who wants to know. Okay, for those who actually wants to solve this. Take note, I want to find the number of silver balls that is added. So usually if you want to find something and it is sort of not given to you, algebra helps you over here. First step, we always let it be a particular variable. Usually that applies over here. If you want to find something and diagram usually not given, you will let it be a variable. Help you all get something. If there's nothing, you sort of give birth to something. Okay, that sounds not right, but you sort of write something to give you more information. So let the number of silver balls added be x. Okay, so with that, I'll give you about 1 more minute. Okay, because this one is for those who have not attempted. 1 more minute to attempt this before I start the bubble launcher in 30 seconds. So I'll start the bubble launcher about 2:32 past 30 seconds. You don't need to know the original number of silver balls. You just need to know this. Denise, you just need to know this. Then you can solve already. Okay? You just need to know this. Or in fact, if you want to know the original number of silver balls is 5. 5. Okay, I'll launch it in 20 seconds. Okay, launching in 5 more seconds. Just bear with me. Last 3, 2, 1. Alright, launching it now. Key in your responses. Let's go. Okay, that's good. Alright, for the rest, just hang there with me. Alright, last one. Okay, sounds like most of you got it down. That's a good note. Let me take a close look. Okay, for the second one, for those who have attempted and try the other do the other option, just be careful with your manipulations, alright? But look at the question. How do we tackle this first? Okay, so what does it mean? If I add more silver balls to the box, it's now 2 over 5. So let's think about it this way. Okay, I add, say in this case, x silver balls. Okay, initial number of silver balls is 5. If I add x of them, it's gonna have a total of 5 plus x, right? That's the fraction. But now let's picture this. Initially, I have 17 silver balls. If I add x of them, what is going to be my new total? Can anybody tell me? What is going to be the new total over here? Is it still going to be 17? Very good, Kavya. Very good game, bro. Denise, awesome over there. Alright, good job. Because what we are doing over here, silver balls are added to the box. You're adding the silver balls, and as well as every ball inside the box, you're adding another x balls over there. So the total will increase by x as well. The hardest part is to get this equation over here, where you realize this is the initial amount of silver box. This is the initial total over here. Okay, initial based on what I have over here. So with that initial over here, which is the number over here, initial silver, initial total. Okay, let me just write it down for you guys. Initial silver and initial total. Once you have this, all you have to be very careful, this is the sec2 content. When you cross multiply, be very careful. 5 plus x equals to 2, 17 plus x. From here, when you expand, just be very careful. Expand into both terms. This is where you have learned in sec1, your distribution law. Over here, 25 plus 5x equals to 34 plus 2x. Simplify further, 3x is equals to 9, x is equals to 3. Therefore, the number of silver balls added is 3. Alright, just finish off with this sentence. And that's why it's like such. So this is how we tackle this question. I hope you all got the thought process now. Okay? Now, I think some of you are here because of one particular question that is kind of hard, but we are going to get to that soon. But before that, let's get on to one question that I feel I should go through. Okay, so find angle ABC. So look at the keywords over here. Why do I do it this way? Okay, regular hexagon means what? All the sides are equal. So every side over here are equal. But angle ABC, what is angle ABC? It's the interior angle. We call interior angles of any polygons. Okay? If I were to sum all of them, interior angles of any polygons, okay? For, in this case, an n-sided polygon. Recall what we have learned so far, n-sided polygon. It's going to be your typical formula, n minus 2 multiplied by 180. In this case, hexagon, 6 sides. That's where we have 6. But why can I divide by 6? Because of the word regular. That means every angle is the same. So therefore, I can divide by 6. And this is my answer over here. So the key thing over here to whether you can do the division or not for hexagons, it's the word regular. So just take note for that for this particular question that I'm going through and be familiar with this formula as well. Bring it down further. Question 13. Now, to prove congruence and to see how we can actually solve this, okay, very, very crucial. One thing, all right, first thing to take note before we even go on to solve and say, oh, how do I know it's SAS? How do I get on to doing all these particular steps over here? First things first, over here, okay, regular hexagon, okay, that's not a concern. Try to actually have the habit of writing the corresponding vertices over here. So what do I mean? A corresponds in this case to E, B corresponding to F, C in this case corresponds to A respectively. Okay, so now let's look at the question. We know it is going to be a regular hexagon, so all my sides here are going to be the same over here. Picture this accordingly. From part A, we have solved that this angle is actually 120. Okay, so write down all the information you have and how do we approach this proof? Now, before we get on to see what test we use, right, we need to know all the particular tests of congruence that we actually perform. So can anybody name me a particular congruence test besides SAS in this case? Any test that we can do besides SAS for congruence, to prove congruency? Anybody wants to try? Okay, very good. Kavya name it. Oh, perfect. All right. So Denise have mentioned one. Very good. Kavya given me all. Very good. So I'll write down one first. I have RHS. Kavya has given me all, but for the rest, let's think about it. What is a particular test we can do? Okay. So let me give some time for the rest to try. Good job, Kavya. Good job, Denise. Thank you for the input. For the rest, I'll give you about 5 more seconds to try this out. Okay, so very good. I have some responses. So I have SSS, SAS as mentioned. In this case, I have ASA or AAS. Now, First things first, we list down all the tests, and second thing, we can eliminate some of the tests that is going to be used over here. So first test, immediately I can eliminate. Can anybody tell me which test I can just straight away say, oh, I'm not going to do that test. It is very obvious that I do not need this. Very good, Kavya. Anyone else? Very good, Gabriel. Very good. I think most of you all know that. I can straight away eliminate. Very good, Denise, this one. Because R over here, RHS, right angle, hypotenuse, one side. There is no right angle for me to work with, so therefore I eliminate that. Next one over here. A little bit hard for me to eliminate, but based on this, I can eliminate straight away another one. What is another one I can straight away eliminate? Because I have this angle given to me. Very good, Kavya. Anyone else? What is another part I can eliminate? Okay, so you realize since I have one angle given, okay, Kavya has given me the note. Thank you very much. I can eliminate SSS. Very good, Gabriel. Perfect over there. So once you have this, you realize all I need to do, maybe find one more side or one more angle to help us solve this. So let's take a close look. Okay, now we have all this information given to us, and we draw out the triangles that we need to prove. ABC, and in this case, EFA. Taking note that in this case, this is a regular polygon as well, or regular hexagon to be more exact. Can I actually say this is actually 120 degrees? With that, you have AB is equals to EF, that is one side of a regular hexagon. The angle that is given there as well, 120, that's the interior angle, S, A, and last one, I have another side that is regular, BC is equals to FA. So take note, you realize when I write it correspondingly to the vertices, AE, BF, accordingly, same thing as well, to BC, FA as well, as they correspond. So with that, SAS, that's how I get to this notion over here. So what is the thinking process for such a question? Okay, look at what you have, look at what the question provides you, and you can eliminate what is not required. And from there, if it's unsure, try to see what you are provided with more, and the triangles you need to prove whether congruence or similarity with. This concept actually applies to similarity as well. Okay, so take note from there. Alright, now, okay, last question for this before I move on to the next one. That I think, next one as well, okay. Name this quadrilateral. Why is this a kite? Because, take note, okay, you have four quadrilaterals, a kite, trapezium, parallelogram, all these things over here, but definitely it does not look like a trapezium. And over here, I'm looking for two pairs of equal adjacent sides, okay. In this case over here, I know that these two are equal, and we know these two are equal as well because they are congruent from part B. So that's where you have to know your conditions of your different quadrilaterals. In this case, two pair of equal adjacent sides over here. Okay, this is two pair of equal adjacent sides, and that's the kite over here that we need to take note of. Okay, and the rest of the other properties. So example for trapezium, at least one pair of parallel sides, which does not apply here. Parallelogram, at least two pair of parallel sides. Not at least, you have two pair of parallel sides, which does not apply here. So you have to be very familiar, and such questions can come up. Okay? Name the quadrilateral. Alright, so of course when I say name, you do not need to give this. Okay, this one is not given. You do not need to write this. You just have to write kite. You'll get the answer. But the reason why I write this is to sort of explain to you guys why I write a kite as the quadrilateral. Okay, so I hope you all got this down, and let's move on to the next question. Okay, my question number 8. Okay, so for this one, this is a very, very typical sort of like a question that you'll face. But I'll give you some time, about 1 minute before I launch the bubble launcher for this particular question. Alright, 1 minute before I launch the bubble launcher. Okay, gonna launch the bubble launcher in about 30 seconds. Okay, in 20 more seconds, I'm gonna launch it. Last 10 seconds before I launch it. Last 5, 3. All right, let's go. All right, that is good. I see some good responses over here. Okay, that's good. I have about 10 more seconds. Last 5 more seconds roughly. Yes, that's right. I would say so usually you realize the questions we set, actually it's more of a thinking process, and because what happens is this is the first time that I actually setting this system caveat, so we expect to see these kind of questions where you have to apply more. Okay, so you have to apply more. So how do we do this? So I think you all realize that immediately when you see this question, okay, some of you all realize it's LCM or HCF, but think about it this way. Okay? How do we actually see this question and we know, oh, immediately we know it's LCM or HCF. Now, if we think about it, ignore the word lowest and highest, so for the first part first. But think about the word multiple or factor. If you think about this, if you try to find a factor for this question, say in this case, okay, I know I have 3 numbers over here. I have 10, I have 12, I have 45. Okay, so if I write this down, I know it's going to be 2 times 5. Okay, there's a reason why I write it this way. 12 is going to be 2 square times 3, so that's easier to see. 45 is going to be 3 square times 5. So let's take a close look and think about the context of the question with reference to what we are finding. So let's say somehow you are not sure, you find a factor for this question. In this case, my factor over here is going to be, in fact, there's no factor over here. So are you saying that they are not going to beep simultaneously again? Is it possible? Or in fact, let's say somehow when you solve it, you got the highest common factor wrong. You say it's 3. Looking at this question, does it make sense for them to beep again 3 minutes later? Doesn't really make sense over here, right? So looking at the question, you can always ask yourself, if the number you are getting is higher than the question suppose, then it's going to be a multiple. You're finding a multiple of something. Okay? If the answer you're expecting is going to be lower than the question context over here, then that's where you get a factor. So that's where, in this case, that's why it's a lowest common multiple. So 2 square times 3 square times 5. This gives me 180, but over here 180 is the minutes. Okay, so you need to convert it to see clearly. So 180 minutes, we know it's 3 hours. So therefore, we know that it is going to be, they will beep again at 2:08. So how do we know whether we are finding the highest common factor or lowest common multiple? It depends on the context. If the number you are finding is higher, the context of the question suggests that you are finding the number that is requires you to find a bigger, not higher, okay, bigger number, then suppose bigger number, then we are finding a multiple. And henceforth, that's where we find the LCM. In this case, don't focus on the word H and L, focus on the word M and F. In this case, the context requires us to find the smaller number, and that's where we find a factor. So these are the things that you can look out for the highest common factor and lowest common multiple. Okay, now let's move on to the next question. I believe this is the tricky one that we are looking for as well. Look at the question carefully. I'll give you all 1 minute to actually decipher this before I start it out. Alright, 1 minute before I launch the bubble launcher for the rest who did not attempt it. Okay, I'll launch the bubble launcher at about 2:50. 2:50. Alright, I might exceed the lesson a little bit, alright, so just bear with me, but try to see what to do the question. Don't worry. I know what you're doing. I know what you're thinking, Denise. You have attended Mr. Shah's lesson before. I know what you're doing. Don't worry. Don't worry. You will get to that soon. For the rest who didn't know what I'm talking about, then I will get to that soon, but for that one, it's not going to be the last question for this lesson. I do have one more that I want to go through. Alright, launching the bubble launcher in 3, 2, 1. Let's go. Okay, that is good. Look at the question carefully. Some of you are getting tricked over here. Okay. Last 15 seconds. Let's see whether you can save yourself. I want the shaded area as the percentage of the total unshaded area. Okay, take note what I'm finding. Okay, that's good. Sort of, but let's see how we go through. Take note, I want the shaded area first. So the shaded area, if you were to break down the question, the radius of the large circle is the diameter. So therefore, the radius, it's half of it. And the radius of the intermediate circle, so this is the diameter. I want the radius, so it's going to be 1/4. Okay, so therefore, what is this? Okay, what this is, okay, the shaded area. If I want to find the shaded area, you realize it's the intermediate circle minus the small circle. So how do I find it? Okay, shaded area is just going to be pi of the intermediate circle radius minus the small circle radius. Applying it, that's where I get 1/4 pi r square minus 1/16 pi r square. That's going to give you 3/13. Now take note, some of you all do this and straight away divide by pi r square. That is not correct, because what happens? I want as a percentage of the total unshaded area. So I actually need to find my unshaded area first, which is the total circle pi r square minus 3/13 pi r square. This gives you, in this case, wait, let me take a look. It's not 13, sorry, it's 16. Apologies, it's 16. So in this case, therefore, it's going to be 3/16 over here, which then gives me 13/16 pi r square. Lastly, when we find the percentage, this is going to be where you divide. 3/16 pi r square, shaded area as the percentage of the unshaded area. Because percentage I multiply by 100%. So that's where I cancel out the common term and simplify it, I get this one over here. So be very careful for those who have answered 1, okay, because I'm finding as the total unshaded area. Henceforth, this is my answer over here. Okay, not number 1. Number 3 is the intermediate circle, so take note. Number 2, you're just finding the area of the small circle, alright, with reference to the total area. So take note, look at this question. Shaded as an unshaded area. So always read the question carefully, okay? Now, now, what is the last question they talk about actually? Yes, in fact, why is the next one the last question? Because I want to go through specific questions. And the next question I believe you are trying is this one. Correct, Denise? Is it this one? Alright, so I will give you all, in this case, instead of 1 minute, I'll give you all 1.5 minutes. Look at the question carefully before I launch the bubble launcher. A lot of people get tricked. So I'll give you 1 minute and 30 seconds for you to attempt this before I launch the bubble launcher, alright? Okay, so take a close look. A lot of words, so that's where you have to read very carefully. I will launch the bubble launcher in 1 minute time, so 2:55. And that's where for this question, I need you all to actually listen to the explanation for those who are unsure. Very important. Yes. So that is the hardest part that we need to take note of. I know where you're coming from. So this is this thought process that you need to take note of, especially for one sentence. I think everyone is like, huh? Why is this question sounds so hard? Is it like a devil question? In fact, I would say yes and no. It seems a lot of info, but if we were to dissect them, it is actually a little bit easier. All right, so I'm gonna launch it in 15 seconds. Okay, so Kavya, I think you know what the correct answer is, but don't worry, for the rest, give it a shot. I'm gonna explain it to you, what it means, okay? Okay, launching it now, let's go. Yes. I have some of y'all that fell into the trap already. But don't worry, last 15 seconds. Yes, that's good. That's good, Isabel. All right, so that's good. All right, if you manage to actually see this info, it is actually quite good. And let's see, I think this is a very long question, hard to respond. So what is this thought process that gets everyone confused over here? So that you realize there's a period of transition for this question whereby there's a before and there's a after. So usually this kind of questions like to give before and after because there's a change. And when there's a change means what? It's more confusing. And it's more confusing means what? These are the type of questions that will mainly give out to you. So am I evil? I don't want to be evil, but I have no choice to make sure that you guys are ready for this. Okay? So one way to think about it to make sure that you guys don't really draw models. No. Isabel, it's not 126. As a lot of y'all say it's 126. I'll explain to y'all why it is not 126. Okay, so what I will do first, instead of depending on models for this question, if you depend on models, it might be a bit hard. So the first step to actually do is to represent it in algebra. Okay, let's see. Okay, so let x. So let's see what we get. Don't worry. I will go through it in a while. Let x represents the cards in units. So in this case, if I have 3 times x cards, I'm just representing in units. Now look at the before. Okay, this is the part that gets a bit confusing and goes boom. Okay, look at the before. So look at the before. What does it say? A is to B is to C. Okay, we don't know what is it. Okay, ratio of Alicia's card to Benson is 3:7, right? So we know it is 3:7. And Charles and Alicia have the same cards. So therefore, 3:7:3. And because x represents the number of cards, I want to find the number of cards. Each one of them, I'm going to multiply by x. This is 3x, 7x, 3x. This is the before. After, what happens? After Alicia gave some card to Charles. Now, I don't know how much Alicia gave. But what did the question say? Question say, Benson to Charles have 3:2. So in this case, again, multiplying by x to give the units in x, I have 3x, 2x. Now, let's take a close look. We need to know how much Alicia is, right? We don't know it yet. But has Benson changed his number of cards? In the scenarios, only Alicia and Charles have actually changed the cards. Benson did not. So therefore, can we say that these two are essentially the same? And what we can do, one side we multiply by 3 and 7. So let's multiply by 3, 3, 3. And at this side we multiply by 7. I think this part is okay. Okay, and then because I have just 2 more questions, I'll exceed the lesson by 5 more minutes. Okay? So just bear with me. You can no need write units in x, but it is just saying that this represents the cards they actually have, Denise. So we write it in x to make it easier. We don't really want fractions. So that's where we have 9x, 21x, 9x. And the other side is 21x, and in this case over here 14x. Now, 21x is the same. Nothing has changed. This one I believe you are okay. The period is 5x. Some of you, that's where you'll find the trap. Is it 5x equals to 30? Take note, Alicia gave some of her cards to Charles. So you realize there is an increase in Charles' cards plus 5x. But take note, because if I give to Charles where Charles cost to increase, there must be a scenario in this case, because since Charles' cards increase, because Alicia gave out her cards, the number of cards will decrease. Correct, Isabel, that's correct, because Alicia cards decrease or Charles cards increase because Alicia gave her cards. So therefore, this part over here will be a decrease on Alicia's side. Yes! You got it, Isabel? So that's why in this case, over here, we need to compare in the same time region, and there is the difference over here to be 30. I hope you get why now the answer is 63, because once you get this thought process down, okay, I sound very excited because this is a quite interesting question. That's where we have 14x minus 4x equals to 30, 10x is equals to 30, x is equals to 3, and I want to find Benson. Benson is the same for both, so 21x is equals to 63. Okay, so that is why it is 63 and not 126. If you are toggling between these two options, it's good. It's good. If you're toggling the other two one, it might be a manipulation error. So just take note. Okay, now with this notion, I just have one more question I want to go through. So just bear with me over here. As such, do I want to go through this question? Let me just see over here. Do I have enough time? Let me just take a close look. Okay, in fact, what happens, I don't want to exceed too much time. That is actually it for me today. Thank you very much for the time. And I'll actually just proceed to the tip of the day. So what happens, as for those who have attempted this paper, we know good time management is essential. Okay, don't get stuck on the current one. Let's say the ratio, let's say in this case for the, let's say the circles question. If you don't understand what the question is saying, you don't get on and try to start yourself there, and then for 5 minutes, 10 minutes, 15 minutes, and you cannot finish. So what you can do, you proceed to attempt the other questions first. But of course, if you have time, remember to return to it. Okay, so that's actually it for me today. Thank you very much all for your time. I appreciate and understand that it is good that you guys have understood what I'm saying. Okay, so carry on, proceed, and I hope you'll attempt the second part of the mock paper, which will still be gone through. So this is only actually half of this paper one. If you do have time, attempt the other half by Kavya, attempt the other half, and I hope and in this case, if you attempt the paper, what I'm saying, if you attempt the paper, it will be more fruitful for you. Okay, but then again, don't worry, we will try to adjust accordingly. And until then, this is Teacher Jason signing off, and I'll see you all next week, same time, same day. Alright, thank you everyone. Bye bye.